Hi everyone, welcome to our next Flask video. In the last video we learned that the browser makes a GET request to our web server to retrieve the HTML content of a website. But what happens if we want to send additional data like a search keyword to our web server? In this video I will teach you about POST requests and how we can send data from our web client to the web server. The key element for requesting data from our user are HTML forms. HTML forms can be used to request user inputs. The data that the user enters is then sent from the client to the web server. An HTML form is indicated by the form tag. A form can contain one or more elements, such as text inputs, checkboxes, radio buttons, and a submit button to send the data to the web server. The most used form element in HTML is the input element. It allows the user to input data. The tag element is called input, and the type of the input element decides which kind of input the field should take. Valid arguments are, for instance, text for asking for text input, password for asking for a password input, which means that the user can type in text, but it will not be visible on the screen. If you set the input type to radio, it will be a radio button, which means that you can select one out of n options. And if you set the type to submit, then it will display a submit button for submitting the content of the form to the web server. The other important element attribute is called name. The name attribute is used as an identifier to access form values. This name will later be used in our Flask server in order to access the content of the different input elements. Here you see a simple HTML code of a form, and below what it looks like once it's rendered on the web browser. The first two input elements are of type text, which means I can, for instance, type in my first and surname. I choose meaningful name attributes so that I can later on easily access the values in my Flask server. The third input element is of type password, and you can see that the content of that input element is hidden. The last input element is of type submit and is rendered in the web browser that the user can click on. But what exactly happens when I press the submit button? How does the browser know where to send the data to? I have not told you yet a key part when defining forms. It is the action attribute in the form tag that specifies where the data is sent to when a form is submitted by pressing the submit button. The action attribute takes a URL as a value, and it is this URL where the data will be sent to. In addition, you can specify which HTTP request type you would like to use in order to send this data. In this example, I use the GET method, but in general, it is recommended to use the POST or the PUT method when submitting forms. This form sends the data to the bing.com/search URL. I have one text element, which I call Q, and I also specify a default value by setting the value attribute. The rendered form is shown below. Let's see what happens if I press the submit button. I ended up on the Microsoft Bing website with the same search term that I ended up typing in my form element. You can see that I ended up on the URL that I specified in my action attribute, and that the value and the name of the input element was passed as a URL parameter. In this case, the form element had the name Q, and the value of the form text element was blue elephants. Now that we understand the basics of HTML forms, we want to develop our first Flask web server that can handle form elements. I create a simple Flask server in the Python file server.py. As usual, I first import the Flask class, and because I also want to use the render engine, I also import the render template function. Next, I instantiate the Flask application as usual. Now it becomes exciting. I created a new function called login and used the route decorator to tell Flask that function is associated with the /login URL. The purpose of this page is to show a simple HTML login form. Instead of writing the HTML code here directly, I use the render template function and call the login.html template, which I need to write next. This is what my simple templates login file looks at the beginning. At the moment we have an empty form. Now of course we need to enter some input elements. First, let's ask for a username. I use an input element with the type text and a descriptive name, here username. Next, let's add another element asking for the password. Again, I use an input element, but this time I set the type to password and I use the descriptive name password so that we can easily access it later. Finally, let's add one more input element of type submit, which will render our submit button. The last thing that we need to do is to call the app.run function in our server.py. Now we can execute our server.py script, and when we visit the URL, then we see our form. But wait, we have not yet specified an action for our submit button. So this is what we need to do next. Back in our code, now we specify an action. We call it here handle login, and we specify that we want to make a post request once the user hits the submit button. Now let's see what happens when we fill out the. Now let's see what happens if I fill out the form and enter the submit button. You can see that the server received a post request to the handle login URL and responded with a 404, which is an error indicating that this page was not found. So this tells us that the form sent the correct request to the correct URL, but of course our server cannot handle the post request yet because we have not implemented it yet. So this will be our next step. To achieve that, we create a new function called handle login, and we use the route decorator to create a Flask handler that accepts post request. The URL that we would like to target is /handle login, and we use the methods parameter to specify that we would like to accept post requests. But how can we access the data that the user typed into the form and that was sent to the server? The form data is available through the request attribute that you can import from Flask. The request attribute contains a dictionary called form, which contains key value pairs for any element in the form. In our case, we had two form elements, one with the name username and one with the name password. So we extract both of them and store them in a username and password variable. Finally, we use a simple if statement to check if the user typed in the correct username and password, in which case we return a simple message that you are logged in successfully. In the case where the password was incorrect, we render the login.html page again, and we pass in the error message as an attribute. Back in the login.html template file, I added this if statement where I check if the error attribute was passed in which case I show the login error in red color text. Now let's see if our server works as expected. As you can see, the login page is rendered again, but this time with the error message. Now let's log in with the correct password. And we see our successful login message. In the last part of the video, I would like to show you how you can create interactive maps like this one using Flask. Here you can see a map of Norway with the COVID-19 numbers, colored in blue. The higher the COVID numbers is, the darker blue the fylke appears on the map. We can also hover over a fylke in order to see the exact numbers of COVID infections. Our goal here is to develop a Flask web application that replicates the functionality of this plot. I like to break down this task into two steps. First, we develop the plotting functionality using altair without Flask, and once we are happy with the plotting, then we build the Flask server around it. This data is contained in this table, where the first column contains the fylke in Norway, and the second column, called incidents, it contains the infection numbers. I defined this data as a Python dictionary and converted to a pandas data frame. The second dataset that I need is the geographical information about the boundaries for each fylke. Luckily, Altair supports a specific data format for storing geographical information called topo.json, and we can use the function topo feature to load in such a topo.json file. I found a topo.json file that contains the boundaries of each fylke in Norway. In the second step, we use this data to set up our Altair plot. If you want to know more about Altair, I recommend you to watch the Altair video that was previously published on this channel. Finally, we can look at the resulting figure. We get a very similar map to what we have seen on the official website. And we can also hover over the different fylke to see more details about the cases. Since I am now happy with the plotting functionality, I store the code in a Python module called plots.py. Now we can develop our Flask application. We start with a very basic Flask application. with a single route called Norway plot. In the function definition, I use the Norway plot function that contains the plotting code that generates the altair plot of Norway. I then use the save function of the altair figure to generate an HTML representation of the plot. I then load the content of that HTML file and then return it. The only problem with this implementation is that we use a hard-coded file name. This is problematic because multiple server requests might be made at the same time, resulting in potentially multiple processes trying to read or write into the same file. In order to overcome this problem, I use the temp file module to automatically generate a unique temporary file in which I can write the HTML content. With this in place, let's see if our implementation works. When loading the URL Norway plot, we get exactly the same plot as in the Jupyter notebook, and we can also hover over the fylke to see the per fylke data. The only problem with our approach is that it works well for a single plot, but it does not work so well if we want to show multiple plots on the same page, or if we want to dynamically replace or update data on user request. For this reason, I will now show you a second solution where we will first load the plotting code and then as a second step load in the data that should be plotted. This will allow us to load different types of data on user requests or even update the data live without having to reload the page. It will also allow you to have multiple plots on the same page. To understand how this works, let's look at the source code of this page. You can see that the HTML code is relatively short and that the actual plotting data is stored in JSON data as a specification or spec variable. We will now change our implementation such that we will offer one Flask resource that serves the HTML code with an empty spec variable and a second Flask resource that will return the JSON content marked here in blue. Finally, we will change the HTML code such that the spec variable is automatically loads the JSON data when the page is loaded. To begin with, I created a new template file called norwayplot.html, where I copied and pasted the code into right, but replaced the content of the spec variable with an empty dictionary. Back in the server code, I changed our Norway plot resource that it simply renders the template. As the second step, we will now create a second resource which should respond to norwayplot.json and which should return the plotting data that is shown here in blue on the right. Luckily, the save function of the altair figure can generate this JSON when a file name is provided. So all we need to do is to save the figure as a JSON file and then open it again and return its content in the function. And again, instead of hard-coding the file name, I use the temp file function to generate a unique temporary name. With this in place, we can now test our server. If we call the URL norwayplot.json, we get exactly the JSON content that we had removed from our HTML template. And if we call the Norway plot resource, we get currently a JavaScript error telling us that we provided an invalid specification. If we look at the source code of this page, we see that indeed our specification is currently still an empty dictionary. So the last step is to dynamically fill out the value of this spec variable. To achieve that, we need to make some JavaScript which is executed on the browser when the page is loaded. We only need to touch 3 lines of code. First, we call the fetch function, which makes a GET request to fetch the content of a web page. In our case, we are interested in the content of the resource norwayplot.json. I also use the await keyword to tell JavaScript that it should wait with the execution until the data is received. The result of this function is stored in the variable response. In the next line, I call the JSON function on the response data to extract the underlying JSON data structure. Again, I use the await keyword and I store the result in the spec variable. With this, we keep the same naming convention as in the original code, so we do not need to touch the other code lines. Finally, in order to use the await keyword, we need to mark the function in which our code is called with the async keyword. With this in place, we can test again if our new implementation works. Now when I load the page, our plotting works again. When we look at the log file of our server, we can see that we first made a GET request to Norway plot and then Shortly after, a second GET request was triggered for norwayplot.json. This GET request was automatically triggered when the page was loaded through the JavaScript call. With this new implementation, you now have the options to dynamically load in new data on user request without having to reload the pages or, for instance, have multiple plots on the page.